Hey guys, welcome back to my channel. So today we are going to look at group anagrams. Again, a Leetcode problem. So given an array of strings, group the anagrams together. You can return the answer in any order. Okay. So we have array of strings given here, and we need to group them based on the anagrams. So what is an anagram? An anagram is basically two words having same frequencies, meaning you see this particular group here, NAT. Now this is also NAT in a different jumbled up order. Okay, so that is what we have to do. We have to group all those words which have the same characters and present in same frequencies. Okay, so and the constraints given is it consists of lowercase letters. Okay, let's look at an anagram. Peach, and its anagram is cheap. Now for these two, we are going to arrange the characters in ascending order. Okay, so we'll have A, C, E, H, and P. Hope I'm correct. E, yeah, right. And then we do the same thing for the other word. Sorry, A, C, E, H, P. Okay. So as I mentioned, anagrams are two words having same characters in same frequency, meaning A is one time in this word and A is one time in this word. And same goes for C, E, H, P. Okay, it's just a different rearrangement. So let's see how we resolve this. So basically, this question requires a list of string as the return type. So what we are going to do is we are going to take a string, like we have array of string given here, so we will be taking each of the string and we will break them down into characters, into a character array, and then we are going to sort it as we did here. Okay, and as we sort it, like we will come across a key. So we will make this sorted characters again back to a string, and we'll have something like A, C, E, H, P, and this will be our key. Okay, this will be our key, and whichever words in this string array has A, C, E, H, P, that will be added to its value section. Okay, value section. So if we suppose we had peach and cheap in our string array, then peach would come up here and cheap would come up here. So we would have two words like which are mapped to this particular key. So the same thing has to be done for this array of string. Okay, so let's go. So we'll create a map of string and list of string. And then we need to iterate through the array of strings. We are going to convert each word into a character array. And then we are going to sort it. So once we have sorted it, we have like characters in an array in sorted order, and we need it in a string. Why? Because our map requires a string and its value. So that's why we are creating a string from a character array. And then we are going to put it in our map. So in our map, if it is not present from before, so that will be put if absent. If it's not present from before, then we are going to add it to a new array list. And if it is present from before, then we just need to get that key, which will be sorted, because sorted is already present from before. So we are just getting the key and adding our string, because these are grouped because these are coming from the question, and this is for all those values which are already present in the map, and that is what we are adding. Okay, so in this particular case, we would see that a and t would already be added as a key in our map. So like nat gets added in the values and tan gets added in the values. So that is the same thing what we are doing here. And we need to return a list of string. So what we return is array list map dot values. So our map has a key part and a value part, and we are interested in getting this because this is where our answer lies. Okay, so let's just run this. Accept it. Okay, great. So the time complexity for this. So the time complexity for this and space complexity for this. So we have n as the length of our string array. So obviously it's going to be n into, we are doing a sorting here, and sorting takes n log n. Okay, so we will consider k as the length of each of the word, and so n log k will be our time complexity, and for a space complexity it will be o n dot k. Okay, so we can make this into o of n. So there's a different approach, and we shall look at that now. So what we would do is we would create a character frequency, okay, in the second method. So for the second method, let me just clear this and this. So in second method, what we would do is we don't want to sort it. Okay, so instead we would create int of character array. Let's call it character count, and its size is going to be 26 characters because we have 26 alphabets in our English language, and we are dealing only with lower cases as mentioned in the question. Okay, consist of lower cases English letters. Okay, so what we do is we would take a word, okay, and go through each of the character of that word. Okay, we would suppose we have eat is our first word, so we pick e and we add it to our character count like this. So what this does is ASCII of A, since we are dealing with lowercase alphabets, is 97. Okay, and for E, so if you calculate A, B, C, D, E, this is going to be 97, 98, 99, 100, and 101, right? So we come to know that we are dealing with E, correct? And since we have a character array, what our character array is having is something like this. Its character is having something like this. Okay, so this is our fifth character, right? 1 2 3 4 5, fifth character. Since it has come across E, this will get incremented to 1. Okay, next we'll go to the second character, it's A. So A will get incremented to 1, and then we have T. So this goes till 26. So wherever we have T, that becomes 1. Okay, so basically what we are trying to do here is we are trying to create a unique signature. Okay, so that is the whole purpose of it. And in case if we have a string that is AAA, so consider this reset. Okay, consider this reset, everything is 0 0 0 0 0. Then if we have a word something like AAA, then this will become 3, and this is how our character array would be constructed for this particular word. Okay, so this is how we would go forward with each and every character, so that we create a unique signature, and that signature is going to be our key in our map. Okay, so that's the whole purpose of it. And then we would create a string builder. Now in this character count, we have our array. We have to iterate through that array and append a separator. So we have to iterate through int array now. So for that, C and then character count. We are iterating through whatever we constructed here. Okay, so we need to add something to our key builder or our string builder here, which is going to construct our key. So to SB or string builder, we are going to append that integer and also append a separator. So this can be a comma, pound, whatever you feel like. We are doing this for a special reason, to avoid collision. Now, why would a collision come? For an example, something like this. We can assume that we will have a string, two strings. That is, the first string would be something like a B and 10D. 2 3 4 5 6 7 8 9 10. Okay, and we have another string that would be B 10 times and a C, and we have to check whether they are anagrams or not. So how we are checking our anagrams here are, we are not checking for the characters, but we are checking for the character frequency based on our character count array. So for this, the value of B we have as 1 and D we have as 10, right? And for this one here, what we have is B is 10 and C is 1. So if I am constructing the character frequency for this, if we are not using a separator, means whatever we append and we are not appending anything extra to that, so my frequency array or the string would become something like this. So as you know that we are to consider for A, B, C, D, right, or all the characters that we have in the alphabet. So A we don't have in this particular string, so we have it as 0. And then we have B is 1. Then C, we don't have C here, so that will be 0. And then we have D, which is this, and so it will go on, right? It will go on something like this. Now again, if we are to construct this count frequency for the other string, we would get, since a is not here, so that would be 0, and b is 10, c is 1, and d is 0. So you see what is happening here. Okay, I pasted it here. Let me just, yeah, we are getting similar string for two strings which are not even anagrams, right? So just to avoid that, we are appending this. So for this, when we are using a separator, we would get 0, then we would get a hash, then b's value is 1, right? So 1, and then again hash, then c is 0, so 0 hash, and then we get 10, and then hash, right? So this is what would be constructed if we are using separators. And for this one, you would see what we would get is, since a is not there, so 0 hash, b is 10 hash, c is 1 hash, and we don't have d, so 0. So this is different than this, and that is what is supposed to happen for two strings which are not anagrams, right? So this is the reason why we use a separator. Okay, now moving on, what we need to do is, after we've created the string builder, we need a string. Okay, we need a string, so let's call it key. So we have added and appended everything in our string builder, and we need to use toString over this. So we are getting a string which is having the unique key for the map. Okay, and we need to do the same thing to the map. So instead of sorted, let's call it key, and we have to return. Great. So time complexity and space complexity. So this is our O of n dot k, right? We have to consider the length of the words, and for this also we have n dot k. Okay, so I'm hoping you understood this question. It's one of the important questions, so do practice, and thank you so much for watching this. Let's catch up in the next video.